since there's just three of us, why don't we just start anyway? Oh, who else? Matt's joining. Nice. I still think probably everyone's met everyone at this point. Gael, do you know Matt? Have you guys spoken?
I don't think so.
Okay. All right. So I optimistically put some extra logos on here. I was okay with the IDML one, I think. I should, actually, Casey, you working for Concordia now?
Yes.
See, I should have put a Concordia logo up. So we can make it seem really official and drop the SAT one since Ed, you didn't show. Unless you're Jean Michael is in the meeting for a short while as well. Yeah, anyway, I'll go through the usual. Well, I think we should do a little bit of introductions since I know Matt and Casey have met, but Matt and Gail have not met. So we can still do introductions and maybe take a few minutes, if you don't mind, to tell me or tell us what you've been up to in terms of, mapping or DMI or interactive system network, especially related stuff, because I'd love to catch up. And then I can very quickly go through just kind of a few things that have changed since last year, some things that I'm working on. I'm on sabbatical now, and one of my missions is to try and take some stuff that's been on our roadmap for a really long time and explore it, and then just chat. But we can go off script at any point. So everyone here knows me, but I'm Joe, and I'm a faculty member at Dalhousie University. And I've been working on this mapping tools related project stuff for like 20 years, I guess, something like that. Anyway, so yeah, and as I said, I'm on sabbatical now. I'm trying to take old brainstorming and roadmap stuff related to libmapper and other tools, and also have a list of a few little applications that I'm working on that's on a slide later on, so I'll leave that for later. Anyway, so I'm in a exploratory frame of mind for rethinking things and trying to expand the concepts and capabilities of the tools. Casey, did you want to go next?
Sure. So I'm Casey Pocious. I'm a part-time faculty in the music faculty at Concordia in the electroacoustics area. But I've been working with the T-Stick and working with the libmapper for a while, since I guess 2019 now, so 6 years. And in my own practice, I'm still doing a lot of real-time performance, audio-visual stuff, but it's mostly moved over to Osseous Score, just because a bunch of the video tools I was working with got deprecated, and I just decided to jump full-scale into Score. Yeah, so preparing a piece that I did previously for another festival for a Live at Kermit this year, and kind of reworking a bunch of my own code with different things. Also had some good talks with Tom Mays about the composition of real-time system that does a lot of modular building of patches that I'm trying to reintegrate into my own practice, but doing lots of things as always.
He didn't get you using Tape Movie from 2002 or whatever it was.
No. Moved to Jitter.
Tom Mays projects, yeah. I'm curious if you don't mind me asking whether using Osseous Score, whether you that your relationship with the piece, just since the main display is kind of time, does that make you, or maybe you were already thinking in kind of scenes or I don't know, programmatically or something?
It does change a little bit, but oddly it's not as much the scene-based stuff. That was some of the stuff I had already thought about in Max. The biggest change was that not thinking about things as inputs or outputs. We can chat more about this later, but like these kinds of things where I could, take a parameter from the granular synthesizer that I was already mapping as, say, an output, and then use it as an input in another system. And kind of this flexibility of data types was, I think, the bigger change for me, because I have to do less audio analysis kinds of things. But
right. Yeah.
we can talk more about that later.
Yeah, for sure. Gael?
Yep. Hi, so I'm Gael. I'm master student at Université de and I've been collaborating with IDMIL at McGill for a couple of years. I work mainly on composing for DMIs, so which with a heavy focus on mapping and sound gesture relationship. I've used libmapper a few times, mostly for my first composition for T-Stick. But now that I'm more experienced, I tend to integrate everything in one software, like namely Super Collider. I tend to do everything in Super Collider, including the mapping to T-Stick OSC data. I'm considering trying again libmapper for to connect to a Max for Live device that's been released by Laboratoire Forme Onde at U2M, which uses concatenative synthesis. It's called Mosaic. So yeah, that's pretty much it. I might go back a little bit to use libmapper for a few things.
Right. Yeah, don't be shy about bugging me about Super Collider bindings. We should dig into those if and when you want to use libmapper more.
Yeah, but just as I was
saying, they need some love.
I tend to do everything.
Yeah.
For me, because I do live performance with a T-Stick, and like I like to have like only one software to open, execute one bit of code, and everything is ready. So
yeah,
but
so
still,
if the T-Stick's running libmapper and you're running Collider, I mean, you don't really think anyway. There's a few ways we can imagine still supporting your workflows.
Yeah,
and it's not it was supposed to be that you couldn't or shouldn't work in your language of choice. It's just about some kind of flexibility when you're connecting with other systems. Yeah. Matt, do you mind introducing yourself?
No, of course not. Can you hear me okay though? Okay. Yeah, I'm Matt Peachy. I'm a PhD student at Dalhousie working with Joe. Right now, I've been doing a bit less of the libmapper direct work. I've been focused on other sort of machine learning, HCI, and DMI tasks, but I've worked quite a bit on libmapper related things from hardware bindings, software bindings, and so certainly interested always going on with the mapping project and happy to hear the updates. So.
Nice. Thanks, everybody. So I'll just go through a little bit of news. We had 3 publications since the last workshop that use libmapper or relate to it. So this is one of them. Matt's first author, and he was referring to some hardware, libmapper compatible hardware that he's working on. So this is for Eurorack synthesizer module. Another one that Matt worked on with Kyle, who was in the workshop last year for the IS2 conference, that was building kind of a WebSocket bridge and then a JavaScript library for allowing libmapper to be used on browser-side JavaScript. And then I was not involved in this one, but by Erdmann von Berg and Stefan. This is another project where they're using libmapper in Frontiers of Virtual Reality. All right, so last year we were crazy busy because we had a summer undergraduate student working along with Matt. So I forget what the number was for commits last year, but it was much greater than this. Again, there were about 60 commits for release. Looking at commit logs, a lot of bug fixes, a bunch of refactoring, which should support the new features that I'm trying to add now. Major improvements to instance handling, especially now exploring devices that have signals that have persistent instances. So they have instances that don't disappear, they don't go, but they're still multiplex. And most of our testing was sort of counting on things being ephemeral, and so that was brought in some interesting edge cases. And then our documentation also improved quite a lot. Some optimizations that should make libmapper run more efficiently. When you have devices that share a graph, then networking is local, but it used to use loopback, and now it just processes serialized liblo OSC bundles. So that's much faster. We actually been working on optimizations to liblo, which were almost released as version 0.33 a couple of days ago, but there was a little bit of a regression discovered, so it should be any day now. And then I'll merge the libmapper code that uses it. But now there's many fewer allocations and deallocations of memory because we reuse the memory for OSC messages. That's also available for everyone using liblo once version 0.33 is released. Also, I've made some protocol changes, which I think I'm safe to merge because I have a feeling that most people are not using or actually, I think I might be the only person using the instance API, that feature in libmapper. But some protocol changes, I am trying to make them backwards compatible, but it means you can send much larger numbers of instances with fewer messages. Some of the refactoring, there's now this, there was already a structure called mapper value in libmapper. So I've just been kind of making it more modular, moved timing statistics into there. I have an experimental API for querying the age of a value, which I think we can use in our expressions for libmapper. So you could make something depend on how long an instance has been active. For example, releasing it after it's been active for 10 seconds if you wanted. And then some questions which I need to bounce off Travis because he was thinking about mapping with data sets, but I'm considering whether, rather than this being a private structure in libmapper, we could make it public and use it, add some API for reading and writing data sets. Within the expression engine, improved error handling. So there were some situations in the evaluator where we might have to, weren't handling divide by zero, or some uncomputable functions like of something that's magnitudes greater than 1. So those are all handled properly, and it allowed me to simplify the linear macro as well. We have some new functions. Some of these I did a kind of systematic comparison with ODOT, and I'm working on one with Placat now, just to look at capabilities and see if there's anything obvious that we're missing. So we have a reduce function called product, same as we had sum and max and min and stuff before. So function for grabbing the sign of a value. Added exponential moving deviation. We already had moving average. Now we have an EMD function. You can reverse a vector. It's a little optimization where if you try to round or take ceiling and floor of an integer, then it internally assigns, so it doesn't compute, doesn't take any computation before it was actually running, rounding integers, like casting them to floats and then rounding them. There's some new syntax for grabbing the instance index within an expression. So that's this hash sign x. X hash sign will be used to actually reference a specific instance index that's not functional yet. $x is used for grabbing the source index if you have a convergent map. All right, merge the quaternion proposal from 2022. Travis was concerned about which representation we're using, but I just decided that we should just document that we're using Hamilton representation. So with W at the beginning instead of the end of that vector. And there's some functions available. And we also have a discussion in the mailing list about adding some additional for converting between Euler angles and quaternions. Still have some things in the merge queue. One is TCP admin messaging, which was supposed to help with Brady and edge use problem they were having in the SAT dome. All right. Any questions about updates? Okay. Casey Gale? No? All right. So here's where things I wanted to, Matt's a little bit familiar with this. He hasn't seen these slides yet, though. I've been working on it a bit since our last conversation. So we have this idea of instanced values in libmapper. And so, for example, a multi-touch interface might have an instanced output, right? So it could have position, velocity, area, and pressure of touches, but the way that it works in the current main branch libmapper is that this is flat. So each signal has its own instances, and then we use an ID map that's in the root device to coordinate between them, so that for a given touch, the position, velocity, area, and pressure signals would have the same ID. And so that allows you to map in a sort of coherent way using multiple instances. We can see in, like, OSC kind of has an implicit hierarchy in the naming because it looks like a URL. Whether you do things in a sensible order is up to you when you're designing your OSC space. But this is what it looks like currently. And we'd like to move to actually using a hierarchical arrangement of objects instead. When we originally wrote libmapper, we deliberately chose a flat representation because we wanted to support arbitrary mapping anyway. So we didn't really care about the structure of the input or the output, whether signals belonged together in any sense, because we just wanted to, as long as we could display them in a sensible way, we wanted people to be able to connect anything to anything. But it turns out doing this allows some optimizations, I guess, making things a little bit simpler, and it'll bring in some features too, which are kind of interesting once we started digging into it. So this way we can have the ID map in the object structure that's actually instanced. It makes it a little simpler. We don't need this argument called signal group that we had before. Now, we always had a problem when you're dealing with, if I map both position and velocity to something, or say that a MIDI input. So we have different instances of note, and they have say note number and velocity. It was a little tricky to do in your callbacks to handle all these instances when they're being released, like which one gets released. One can't really exist without the other, and when it comes to MIDI. So it makes more sense for, in the MIDI example, for note to be the instanced object. So instead of releasing all these signals, you release the object that's instanced. And we have a crazy example that Matt started exploring years ago as a directed studies project, I think, right, originally. Trying to think about a really flexible general representation for hand data. How would we approach representing a hand in libmapper? So we think that we're talking about instances. We have, if we have a hand tracker, it might have as its output multiple hands, which are ephemeral. So they're on screen, maybe they're off screen, maybe the person leaves the room. Each of those hands has multiple fingers. Each finger has multiple joints. Each joint has some properties like position, angle. We also might have an object called bone, which might have orientation as well, right? So before, it looked the way libmapper's hand tracking, we have like a wrapper for the leap motion driver. We had to declare signals for each of these. So this is just the position signals for each joint, right? We had to declare them each, programmatically. We had some lookup tables and stuff, but still, this is a lot of work. And what we'd like to do is go to here. So we have a device called tracker. We add hand, an object called hand to that. We add an object called finger to the hand, an object called joint to the finger. And we can support optional names of instances, but we know that we don't actually have to add them. We don't need separate function calls to add index finger, middle finger, ring finger, pinky finger. Just add an object called finger. So instead of all of that, we'd have essentially 5 API calls here. we have this is from brainstorming that Matt and I did starting years back, but we imagine that we might want to think about instancing when we're mapping a hand in different ways. We might just want to say that each joint is going to control something, so we just have instances of joint. Or we might want to say, I'm interested in the distance between this joint and this joint for each finger. So I want instances of finger, but I want these joints to have the same ID. They belong to the same instance of finger. On the same kind of story, I guess we might want to say, look at the distance between the same joint on different fingers. So I want the tip of each of my fingers instances of something. And so I might skip a few slides, but we imagine that we have something that I'm about to introduce called OSC path, and brainstorming, figuring out how to store and look up the indexes of instances when they're stored internally. But I think we can support all of these scenarios. But the trickier question is, how are we going to build a map that uses instances in this way, right? It would be very tricky, especially if we're thinking of a C API, and would be a lot of function calls in order to specify a specific instance of a specific finger or a specific instance of joint for a generic finger, et cetera, et cetera, et cetera. And so I've been thinking a lot about how to query things in specific and general ways. The OSC 1 spec has wildcards. OSC 1.1, they proposed introducing this path traversing wildcard, so it means descendant and XPath. So doesn't necessarily mean the child, could also be a grandchild, great-grandchild, etc. XPath also has a parent wildcard, so I'm saying we're going to get that as well. But XPath, interestingly, has this thing called where you can add little tests to your path and that have to evaluate to true in order for a given node to match. So this is OSC 1.0. I'm skipping the wildcards, but OSC 1.1, we added just the descendant. It wasn't us, it was the authors of OSC. XPath, other things, right? Like, so this parent, they call it an axis. You have different ways that you can represent relationships in XPath. And if you're not familiar with it, XPath is kind of like a query system for querying and manipulating XML or structured data usually in web. XPath has attributes. So a node could have an attribute, for example, at unit. And then things like predicates. So you can say, I want nodes that follow the structure A or B as a child of A, but only if that also has a child C, but I'm actually selecting B. The same thing when you're looking at a document in XPath, there might be multiple instances of a node, and so you can give it an index. Same thing, you can check whether it has a unit and even say if the unit equals something specific. So supposing that libmapper used something similar, it's not exactly XPath because there's something extra that we're going to add. One thing that I think we can add is in bold for the predicate, I have A, B, C, and then in square brackets D. We have named instances in libmapper which don't exist in XML documents. And so I'm proposing that in addition to being able to use an index, that you could actually use the name of an instance there. So it would be, hand, finger, and then instance pinky, perhaps, right? And same will support units. And then we have something extra, which is relationships between nodes it's very different from a document. It's about data flow. And so I'm proposing that we use the existing arrow symbol that we're already using, like a dash and a greater than symbol, to represent a map. And that way we can query maps from the graph and we can also declare them. So as the examples here, I have A map to B, and also A mapped to wildcard, so that if we queried that from the graph, we would get every map, every structure that involves A mapped to something. We have a little funny thing here, which is it's how are we going to group these? If I wanted to say take my hand data and draw it on a canvas and make one hand be red and the other hand be blue, that's a little tricky because all the instances have their own IDs. They don't have any identifier that says that they belong to a specific hand when they arrive at the destination. And so we imagine we'd have kind of two maps here, one that's mapping position to position, one that's mapping something to the color of the blob on the canvas. And so I'll try to see if I can make this work in terms of implementation. But in XPath 3, they have what they call a map operator, which we may have to call something else to avoid confusion. But this is basically saying for each descendant called joint, we want to recover the ID of the hand. And so basically the idea is that in libmapper, the message that's sent would have the instance ID of the joint, but the value of the message that's passed would be the ID of the hand. So we could map that to color. Anyway, I'll try to get a working demo working, and I'll add it to the mailing list. So we talked about, Travis wanted to be able to start creating maps before things were registered way back in the discussions on the mailing list. And I suggested using something called object promises. And I think that we're kind of almost there now that we can underspecify signals, right? We can describe a signal without knowing anything about it. Such / at position would be a position attribute of any object. And so that could be new objects that are going to exist later as well. And we also might be able, if we declare the map in this way, we create a new map with / at position, then we're saying, I want to map anything on the graph, anything in the whole distributed network that's called position, that is a signal, to map that to the offset property of a grain. And the way libmapper works is each of these would control a different grain of the synth automatically. That part already works. And so we might imagine, who gets to hold the spec for the SPAP? Do we need to be able, do I want to be able to distinguish between creating a map between things that exist on the network now versus leaving it open for new devices to join later? So I could have a session manager. I give it this map, even though there are no devices in the network with signals called position. But then later on, they show up and they would automatically start sending their data to control the grain, this granular synth. So this is this position would be anything with a signal or / property name position. And that's to an interesting question. libmapper has signals and it also has object properties. And to me, it's always been a bit funny thinking, because I was never really sure why we had both. I mean, I wrote the code probably, but it's because you can update object properties, so we can't really say that signals are dynamic and properties are static. The thing is, you can map signals and you can't map the property. Seems like not a good distinction. So I think probably they should just be merged. And so all objects will have properties, which you can treat as signals. It does mean that we can't have signals have their own properties, because that would be property setting properties, and that would get, I think, too confusing in terms of what's mappable. And perhaps all properties will have an optional unit min and max. All right, that's it for my proposal for library updates. I'm curious if one thinks that they have a, is this kind of mapping scenario interesting for you? It's a lot closer to old style OSC wildcard matching, but using the same API, you can create maps and then modify them. But the expression would actually, describe relationships between things that could be coming and going basically from the network.
Yeah, I mean, this seems quite interesting. I've had quite a lot of luck with wildcard matching with Spat Revolution. And like when you're dealing with lots and lots and lots of objects, this kind of stuff becomes really useful.
Mhm.
Even with basic OSC, I think most folks don't even know the wildcards are there. So I think this is also like if we do have some working demos, this is a good way to show that those capabilities are there. Even if folks move to other things outside of libmapper, there's the pedagogical interest there that makes sense to me.
Yeah.
And
maybe maps are less constraining now if they can describe them. You still have the option of declaring relationships between specific things, but if you underspecify them, then yeah.
And it could maybe save a bunch of grunt work that I've run into with like when we update the T-stick and we go from 16 capsense sensors to 30. There's probably some better ways now to dynamically update these things, so you don't have to go and update all of this by hand. But again, like how clear is this for a basic user? I'm not sure, but that's also not really our use case concern from what I see.
Yeah.
So
I have some sketches of how to use WebMapper in this context, right? Which is a little tricky. Like, do you, like basically it could just allow you to play with some patching perhaps and filter the namespaces. So, and then every time you have something that could be treated as an instance, like as an instanced object, it would allow you to drag that, if that makes sense. So if we have fingers with joints, then you'd also be able to drag kind of generic finger with joint, even though there's options for instance, for index, middle, ring, pinky. But if you wanted, you could just, and that would happen. I'm imagining that would just happen automatically. It's not, no one would have to declare a generic finger object. We would just automatically, because we're already instancing stuff anyway, we just allow you to view it that way. Yeah, so maybe that would help with some users anyway. Kind of our ethos is supposed to be, and I think we've done a mostly good job, is to support people thinking about it in different ways, different representations. So one thing that this will be able to do that wildcard matching can't do in OSC is that our instances still have like identity, right? So they carry IDs with them. So you can coordinate them across the graph and even like, have some intermediate device that's processing some of them and not others, and they'll still retain their IDs across the map. And so it releases the right thing when the instance goes away, and it's a lot of stuff that should happen automatically.
Which is a pain to try and do in programming languages when you're trying to just use the OC wildcard stuff.
Because different elements or different results end up representing different things.
And you end up with some really, at least I played with some stuff in Max and ended up with some really ugly if statement code. Where it's like, look at objects 1 to 5 and then 7 to 10, and like these sort of odd groupings that, if they hold on to their IDs, you can just call them all one thing and it becomes much easier.
So I'll come up with some demos as I get it working. And I also have some ideas like in my brainstorming lists for better demos of instancing that kind of show off, because I think most people don't realize what a powerful feature. And it took years of work to make it work. So,
well, specifically with SPAT, it could be rooms and objects, because that has been a pain point. Rooms and objects are kind of their own separate data types, and the sources are ignorant to what rooms they're in, and the rooms are ignorant to what sources that they're in. So being able to do this hierarchically from libmapper would, like, you wouldn't have to actually touch anything on their end. So
I'll add that to my testing testing lists. Maybe, I don't know, I've been talking a lot. Does anyone else want to add something? I have a couple of little mini project ideas run past you. Well, I'll just tell you about them because they exist as stubs now. I'm working on them. One is based on the existing signal visualizer that I made that's in the libmapper contrib repo to make an expression explorer. So it creates its own signal and allows you to play with different expressions and show them side by side, or one on top of the other currently, and then push it to the so you can kind of stick it in the middle. So A maps to expression explorer, maps to B, and then you can push it to just be between A and B if you want. So you can kind of pick up a map, look at how the source and the modified version are changing together, and manipulate that. Maybe try out some other options and also see them in parallel. So I think that'll be pretty fun for messing around with expression syntax. Next one is, I'm calling it Scrapper. So it's like scripting mappings, and the idea is that it would be a little bit like Field, if you're familiar with Field, in that you write code. So it's like a live coding kind of canvas or whatever, but what you're writing is mapping connections. And then, I don't know, maybe you also make some signals, I guess, but mostly you're writing mapping connections, and the interface would also show you some live state about, whether a mapping's active or not, and stuff like that. And the third one is inspired by discussions with Travis a while ago. I started trying to play with making a dataset player where you can just load a dataset. Currently, it handles like comma separated value files with headers and declares signals for each column. And then you can there's various ways to play through it, and the play controls are also libmapper signals themselves. So you can have it control itself, or another dataset control it, or a DMI control the dataset player, etc. Anyway, so if anyone is interested in collaborating on any of these, then I'm not sure if I pushed them to GitHub yet, but that's my intention, is to develop them kind of out in the open.
It's worth getting in touch with Jean-Michel about the dataset player, because in Score they've just added it where you drag the CSV file into the timeline, and it does a very similar thing. It declares every column. But the Scrapper could be very fun. I built some similar stuff in Max that was ultimately bottlenecked by the Max API itself. Mm-hmm. Every receive instance had to parse every message and look at whether or not it was supposed to go for it. The problems with the routing object. But I mean, libmapper would clean up all of that. So I'm definitely interested to see how that's coming along.
Great. Yeah, well, keep an eye on GitHub, or I can also keep you in. All right. This was pretty quick, but I'm interested in, first of all, I'm interested in talking about what you want to talk about, if there's anything you want to talk about. I have a few, I don't know what these are, maybe areas, they're topics of interest. I'm curious what you think about them. What's important, what's not, what's holding you back from using libmapper or another tool that would be fun to explore. As you know, the libmapper / mapping tools project has two reasons for existing. One of them is to use to make make pieces and DMIs and stuff, and the other one is to explore fun academic ideas about what mapping could or should do. Just kind of try them out without re-implement all the base layer stuff. It's a nice thing about an open source project. Anyway, so one, I know, Matt, you must be thinking a lot about machine learning in these contexts, right? Because that's your main project right now. Obviously, machine learning is super hot right now. Everyone wants to use it in everything, and so the question is how, what are some interesting ways that it can kind of fit into these contexts. Also talking about mapping audio, video, or matrix data using data sets, as we already discussed. I think batch processing is kind of a follow-on from using data sets. like whether or not it would be interesting to use libmapper to process whole data sets. Version control, that's Jonty's old project, but we still need to handle it. And object instancing I've already presented, but anyway, curious about other people's thoughts. And maybe we wrap up by the end of the hour.
Could you, I know we've talked about it a little bit, but could you sort of describe what you mean, maybe in more detail, about use of ML in data flow pipelines, sort of beyond a little bit of what those bullets say?
Yeah. Well, I mean, I like to think of it as, I'm trying to think of it quite as an open problem, right? Rather than doing specific stuff.
Right.
We've talked a lot about, I mean, part of the reason for thinking about mapping as a way of describing interactions is that it is continuous, and it ends up being, when we describe relationships as maps rather than as state machines or buttons and stuff like this, it allows interpolation and extrapolation in interesting ways. And with only a few maps, being able to set up spaces that have, they're not unpredictable, but they're complex, right? Obviously, you can use unpredictable aspects in your system, or you can use randomness in your expressions. So it's kind of like an easy way to set up systems that also have surprises hidden in them.
Right.
Now, always whenever someone said, "Oh, this is the new tool that everyone should use," we would at least we should ask the question: Should libmapper connect to it? Is it interesting to use that in combination with something else? You can do stuff just in one application. That's fine. There's nothing wrong with that at all. It's just, would it be fun or interesting? Would we learn something or be able to do something new if we use these things in combination? Right now, so like M&M from IRCAM, for example, was this mapping not music tools, and they had a bunch of some machine learning related stuff for building interpolators and like exemplar based mappings, like few shot learning. And so we said, oh, well, that could be an intermediate layer and in a libmapper data flow. So we did that. So now, should we be doing the same thing with different machine learning tools? Is that interesting? Is it useful? Is it fun? So these are questions I like to ask. I think sometimes we only find the answers by trying it,
Sure.
especially if things are maybe going to be surprising.
Yeah.
Yeah.
No,
I mean, so Matt's working on a project now that uses kind of mapping and machine learning. So he's probably been thinking about this a lot, hopefully.
Yeah. Yeah, no, it makes me think, like, not necessarily related to my project, but like I just got back from a conference, AIMC, so AI creativity, where there was certainly plenty of talks sort of about actually interacting with ML models on sort of the weights level, like adjusting weights of a neural network such that you're almost shaping the results. And so I'm curious if maybe one option of that is that instead of just hard coding weights of a neural network and saying actually make this 0.3 instead of 0.5, that if that could be an endpoint, like maybe you build into something like PyTorch, where then either through the training process or through the inference time, you're able to map to weights of a neural network. Obviously, then you're going to get into plenty of interpretability issues or challenges or opportunities. But it might be one interesting way of thinking about it, rather than just predicting what a mapping should be, right? Like if you're given, I don't know, whether it's a T-stick or hand tracking, and then having it sort of predictively pick mappings, I'm not sure which would be more interesting from an ML perspective, but.
Right. Yeah, another version I thought of was using existing maps, like human design maps, to train a machine learning system, So it gets to kind of sample the input and output and train itself, but based on a map that was designed, or a mapping that was designed by human.
Yeah, which is sort of the other option. Yeah, for sure.
Yeah. Right, and could even be, we could think of this as being a little bit like your patch learning tool. If a patch could be a mapping to some hardware, right?
Yep, totally.
Yeah, it's interesting, especially for an analog synth, like a digital controlled analog synth. Yeah, so I mean, I'd suggested for the data sets that maybe we should be exposing the value data structures or a lower level API so that you could kind of directly write to values. Right now, they store instanced or histories of instanced histories of instance values for a given signal. But we can add dimensions, or if you, for something like a data set, the history dimension doesn't necessarily have to represent history. It could be some other dimension. Anyway, we have in the mailing list or in the GitHub issue, I pasted my kind of design space for thinking about use of data sets within mapping contexts. So you can, think of it as a lookup table, or as a file that you play and record, or et cetera, et cetera. You can think of it as like an impulse response if you convolve it with a live signal that's coming in. There's lots of ways we can think of using data sets.
I do also like the, I always remember Baptiste Hermio's GVH, the gesture variation follower.
Yeah.
Because that is also you can kind of train it on what you want it to get in terms of inputs and outputs, but also the thing that I always find useful in terms of mapping is also that you get the variation output as well as the like raw mapping output, which I mean, I think the most interesting use cases for a lot of the ML in mapping is grouping some signals together, but still keeping a bunch of the other signals kind of as a one-to-one mapping. So you don't end up with the, as Eric Lyon called it at ICMC this year, the one-to-everything mapping paradigm, where you just kind of everything gets mapped to all parameters, and it becomes a bit confusing to disentangle the ball for actually sort of building it more into a performance element. But I do also like Matt's recommendation of also being able to play with the weighting and so forth, because that's like Spire.
It's like,
there's I think 5 different weightings that's really performative in some very fun ways.
Well, it's like circuit bending or opening up the piano as a metaphor, right? And you play on the strings. If we have a box,
100%.
Why not be able to stick your fingers inside and mess around with it?
Well, and it's this like, why use machine learning but to kind of get the aesthetics of machine learning made art, not trying to make AI art remake things that we can already do with other mapping schemes that do it quite well.
Right. Yeah, I agree. It's one use of new technologies is to emulate old ones, but it's much more fun to use them in idiosyncratic ways.
Yes.
That couldn't have been done before. Yeah.
Particularly
what does it really mean to make art with machine learning? Should be different from just making it faster to make art that you could have made before.
Exactly.
Yeah. Anyway, I think some of these are kind of open questions that I just I need to keep thinking about. I'll see where it goes. But to the extent that anyone is interested in helping to work on any of things, I'm always open to that. And I'll continue to work on the libmapper features in the open and see what ends up being publishable later. So there's also, if people want to collaborate on that, then or just use the new features in interesting ways. So like Matthias doing the map looper stuff, we kind of pushed the envelope of what libmapper could do to support a particular project, and it ended up being useful in more general ways. But that was like a really fun thing that resulted in a publication and at least demos. I don't know if it was performance. I think at least one performance with T-Stick. Yeah, anyway, that's I have no more slides. You have an idea what I'm working on, and feel free to flag things that you think should be my priorities if they're not, like super collider bindings that might not work properly. But anyway, I'm not a libmapper evangelist. I'm not trying to tell people that they should use the tool. I just think it's what I use for exploring artistic and academic ideas. And obviously there are other amazing tools out there as well. I do need to make a visit to Montreal and sit down with Jean-Michel for a day or two and talk about our stalled integration between Ossia and libmapper to make that a priority too. Anyway, anything else anyone wants to talk about?
Just on the machine learning note, I don't know if you're still in touch with Gabriele Viglasoni, but he might have some graduate students at Concordia now that could be interested in working on some of this.
Right.
But,
yeah. Yeah, I haven't talked to him in ages, so it'd be smart for me to reach out anyway.
Yeah, he's in computation arts at Concordia now, so like I can definitely see some of these things either being projects for his topics in AI and art seminar, or for the folks in the master's or the PhD in design.
Right.
It seems to make a lot of sense.
Yeah, great. Super. I'll do that. Thanks, Casey. Make a note. All right. Should we say our goodbyes? All good?
Yeah, thanks, Joe.
See you online. Yeah, all the best, everyone. Thanks. No,
Thanks.
it's just a few of us this time, but thanks.
Thank you.
Thanks for coming and having a discussion. See ya.
Awesome. Have a good one. Bye.
You too. Bye.
Goodbye.
Bye.